Okay, everybody, we are going to take care of two sections in one. We are now in chapter 5, and we're looking a lot at inequalities. And what we're going to do is learn how to solve inequalities. And if you notice down here, we're looking at section 5.1, which is solving inequalities by addition and subtraction. And then the other section 5.2 is solving by multiplication and division. It's a lot like solving equations. I figure you guys know how to solve equations pretty well. So we're going to just continue on and we'll put these two things together, and I think it'll make good sense. So let's get started. We only have one vocabulary term, and that is set builder notation. You guys are actually familiar with this. What it is a concise notation for writing a solution set. So if you remember when we would talk about, let's say, finding the domain of an equation, right? Or we talked about finding the range of an equation. Let's think about this graph here. So I think you all are pretty much familiar with these guys, right? This would be an absolute value equation. And let's say that this point here is, I don't know, 3. All right, so if we were to talk about the domain, we would say the domain, since we know domain refers to x, would be the set of all x values such that x could be anything. And we would write this situation like this: x is an element of the reals. So what that means is all x, this line means such that x is an element of the reals. X can be anything. The range is going to be a little bit different. Remember, range deals with y. Since the range refers to y, we can look at our graph and kind of think about what y values make sense in this equation, or what y values are being represented in this function, in this relationship here. The y values are all y values that are above 3, above or equal to 3. So what I'd write is y such that, so the range is all y such that y is greater than or equal to 3. And so what this is referred to, and this is something you've seen before, is set builder notation. And we'll be using that during this lesson. So the first thing we're going to talk about, we need to get some properties down. And these properties are pretty basic. These are properties of inequalities that look exactly like properties of equality, except one situation that we're going to look at in the next screen. So what we have here is the idea that if I had A greater than B, or even A less than B, we could also manipulate this by putting an underline here, which means greater than or equal to, but I think for now we're just going to look at it as if I were dealing with A greater than B or A less than B. Basically, what we want to keep in mind is that if I have a C, some other C value, if I add C to both sides, I would maintain the inequality. So if I add C here to both sides of this inequality, it's still the same. The sign hasn't changed. This side is still greater than this side. Over here, this side is still less than this side. This is the same thing with subtraction as well. And I almost feel like I don't have to write this out, but I will, just so you guys have a sense of what the property is. So the properties basically say when you have an inequality, what you do to one side, you do to the other, and that inequality is maintained. Very similar to what we talked about with equality. So in a real life situation, if I said that 7 is greater than 5, or we can even rock a -5, same thing, and I add the same value to both sides of an inequality, let's say 4, right? So I'm adding 4 to both sides. What you'll notice is that 11 is indeed greater than -1, which is 7 plus 4 is greater than -5 plus 4. And so we'll see the same thing with subtraction. Where the thing gets a little bit weird is right here. So multiplication and division seems cool, right? We start off again with some A greater than B, and what we're thinking is that if I take A times C, that should still be greater than B times C. And if I take A divided by C, that should be greater than B divided by C. And same thing if I change the sign around, right? But that is not the case. And this is the property that you really need to keep in mind. What happens? So let's use a real life situation, right? If I have 9 is greater than 3, everybody would agree. If I were to multiply both sides by 3, so let's say C is equal to 3. If I multiply both sides by 3, I get 3 times 9 is greater than 3 times 3. That's true. 27 is indeed greater than 9. Let's divide. Let's see if it works there. So again, starting with 9 is greater than 3. If I divide both sides by C, Is 9 divided by 3 greater than 3 divided by 3? Yes, it is. 3 is greater than 1. Where's the problem, Dion? I'm glad you asked. The problem is when this C term is less than 0, or in other words, when C is negative. A whole host of drama happens when we have it as less than negative. So let's take a look. I'm going to erase this. So let's get back to our example. Let's start off with 9 and 3. Again, 9 is greater than 3. And what we can do is simply divide both sides by. Now I said the problem starts when C is less than 0. So give me a number that's less than 0 that I can multiply or divide C by. Yes, -3 sounds great. So if C is equal to -3, I'm going to multiply both sides by -3 and watch what happens. -3 times 9 is greater than 3 times -3, or vice versa. You know what I'm doing. All right, so I get a -27 is greater than -9. And for a while it feels okay. Then you're like, no, shenanigans, woman. This is not greater. And let's see what happens. So this is, I'm going to put like a big red around here. So if you're just ignoring my words, you'll see that that's bad. So that is not true. And then over here, we can do the same thing. If I started off with 9 is greater than 3, if I were to divide both sides by -3, you'll see that we get that -3 is greater than -1, and again we know that is untrue. The solution is to keep in mind that you can do the same thing on both sides and it maintains equality or it maintains its inequality until you multiply or divide both sides by a negative number. So when C is less than 0, the sign flips. And you guys probably remember this from last year in pre-algebra, but I want you to keep it in mind. So we're going to see that in the second example. The first example, we're not going to have any sign flipping, but the second example, we will. So these are properties that we're going to keep in mind. Let's take a look at a couple of examples. So the directions here in example 1, we've got 4 different problems that we're going to work on and answer. The directions here ask us rather, to solve and graph each inequality. Write the solution in set builder notation. I want you to treat in your mind, in the back of your head, I want you to have in mind that you're going to treat this almost exactly as you would that equation. You're going to process, this is a thought bubble, you're going to process that in the same way. But the only caveat is when we multiply or divide either side by a negative, we're going to have to pay special attention and turn our side around. Oh, I'm not doing anything right. Turn our side around. There we go. Awesome, D. All right, so we're going to divide both sides by the coefficient, which is 4. When I do that, x is greater than 2 over 4, which means that x is greater than 1/2. And so I'm going to erase our thought bubble for a moment there, get that out of the way. So the answer here in terms of set builder notation is the answer to this is all x such that x is greater than 1/2. Not a big deal. But to graph this, we need a number line. And the important number that we're thinking about, since we're comparing x to 1/2, is 1/2. So I'm comfortable if you put a 1/2 there. And then x is not equal to 1/2. It is greater than 1/2. So I'm going to put an open circle here. And we know that numbers greater than 1/2 are going to be on the right side of 1/2. And so we shade this way. And this is how you solve the problem and write it in set builder notation and graph. So that's what we got. Let's rock this one out. So on both sides, I'm going to do what I usually do. I'm going to try to isolate this D by subtracting 2 on both sides. Subtracting is cool. It's not going to cause a flip. It's the multiplying or dividing of a negative number on both sides that's going to cause the flip. And I told you this example doesn't have any flipping going on. All right. So we've got that 5. And so D is less than or equal to 5. I'm going to write that in set builder notation. All D such that D is less than or equal to 5 is my solution. And to write this down, or to graph it rather, I'm going to use 5 because that's the number that I'm really concerned with. Of course, I could write other numbers, but 5 is the important one here. And I know that this thing can equal 5. That's what the less than or equal to means. I write that in, but it's less than is to the left of 5 on the number line. And there's my answer. Here we have another situation very similar. I look at this as if it's an equal sign. I'm going to add 3 to both sides. When I do that, I get 5z is less than 25. Divide both sides by 5. And I get that z is less than 5. Again, set builder notation happens just by doing this. So this reads z such that z is less than 5. And my number line looks like you would think. A 5 here. What kind of a circle should we have here? If you said open, you're awesome. So open, and we're going to shade it down this way because it's less than. And finally over here, draw a line down the center. Let's move this 5 over here, add 5 to both sides. I'm left with 7. I'm going to just move this over because I don't have the space. 7 is greater than or equal to 14f. Divide both sides by 14. When I do that, I get that 1/2 is greater than or equal to f. Now for set builder notation, this doesn't exactly work. I need to kind of flip it around because f is my subject. So f is less than or equal to 1/2. And this is just me moving things around. So I'm kind of reversing the whole situation, but maintaining the inequality as it is. And of course, my number line situation looks as we would expect. 1/2 here, and I'm going to have a solid closed circle, and I'm going to shade to the left because f is less than or equal to. So here we are with example 2, and here is where the drama ensues. All right, so here we're going to solve and graph each, and basically we're going to solve it just like we would when we had an equation. So what I would do in this case is I'm going to multiply by the reciprocal. And notice, by multiplying by the reciprocal of -4/9, I'm multiplying both sides by a negative number. Automatically, this should tip me off that I'm going to have a flip situation. So that's going to flip over. And so now this side cancels each other out. I'm left with x. 4 goes into 8. 2 times a -9 is a -18. So my answer is x is less than -18. And as we are really comfortable with now, I've got my -18 as my number of concern, open circle because it's not equal to, and I'm shading to the left. Over here, I'm going to, what am I going to do here? I'm going to subtract 8 from both sides. I get -d is less than or equal to a +4. Now, I don't want to solve for -d. I want to solve for +d, so I got to divide both sides by -1. As soon as I see myself dividing or multiplying both sides by a negative number, that's indication that I've got to flip. So my information is going to flip around a little bit. I'll get d is now greater than or equal to a -4. And here's my graph. Solid circle to the right because it's greater than. And I think we can do these in the last couple of minutes. So I'm going to move my -4z to both sides of my inequality. I get a -19z is less than 22. I think that looks good. And now I'm going to start the division process. I'm dividing by a -19. When I do that, I've got to flip the sign. So now that the sign is flipped, I get that z is greater than 22/19, -22/19. And not super simple to graph. I guess it is just as simple as anything else. The number I'm concerned about is -22/19. If you don't like the improper fraction, you can change it to a mixed number, but this is cool. And I'm going to open circle, and I'm going to shade to the right because it's greater than. And I think we got the time to do this last one. We got to do some distributing here. This negative outside needs to be distributed through the parentheses. So negative, I can think of it as like a -1. There it is. -1 times 2 is a -2. -1 times a -5 is a +5g. Plus g greater than or equal to 20 minus 5g. Now I'm going to simplify each side of my inequality. I get a -2 plus 6g, which is greater than or equal to 20 minus 5g. Move things over the way I know I need to, which means I'm going to add a 5g to both sides, right? And by adding 5g to both sides, what I'm actually doing is keeping us from having to do that negative thing. Because if I did it the other way, then I'd have a negative coefficient of my variable. I hope it makes sense to you. I know. All right, so I've got my -2 plus this. And now I'm going to add 2 to both sides. I'm left with 11g is greater than or equal to 22. No flipping is involved here because I'm dividing both sides by a +11. G is greater than or equal to 2. I was so scared that I wouldn't get through this. I'm not even going to give you example 3. It's okay. It was I just made it up just so I can have a word problem in there. You guys are ready to do sections 5.1 and 5.2. Ask me any questions in class. I can't wait to see you. Have a good day. Bye-bye.